Joel Rifkin says there was nothing in his past, no trauma or abuse, that can fully explain just why he became a killer. So after his arrest, his attorney ordered brain scans and other medical tests to see if Rifkin had a brain dysfunction that might have sparked the murders. The tests were conducted here at New York's Stony Brook University Hospital.
Dr. Anthony Bolton is a brain specialist who conducted the first medical examinations on Rifkin back in 1994.
He was referred by his attorney, and the question for me was, is there any kind of neurological dysfunction, neurologically based dysfunction?
Bolton put Rifkin through 11 hours of special tests.
He went through a series of what's called neuropsychological tests, and these are tests to measure behavior, in particular cognitive functioning, things like attention, memory, visual perception, language.
Bolton was struck by how normal Rifkin seemed.
In terms of behavioral observations of patients, or in this case an inmate, pretty much unremarkable in terms of his behavior. He was a regular guy, basically.
Surprisingly, he performed very well on most of the tests.
His IQ values were in the above average to superior range, actually. So this is a guy that, if you don't look pretty carefully, you would not find any kind of neurologic deficit. Here we have words, the words red, green, and blue.
But according to Bolton, Rifkin did show some signs of trouble. First, on a test demonstrated here with a volunteer. The test measures whether a person can follow instructions while ignoring conflicting information. Here's how it works.
Your job here is not to read the word, but to name the color that the word is printed in. So, for example, what would you say for this one?
Red.
Yeah.
Blue.
That's right, and this?
Red.
Yeah.
And green.
Right, good.
The trick is to ignore the written word and instead say the color it's printed in.
Go.
Blue, red, green, blue, blue, green, red.
There's the tendency, and we would all have this tendency.
I'm sorry, that's red and blue.
To
green,
read the word.
blue,
That's the natural
green,
tendency.
Red, green.
Halfway
blue,
through the
red,
test,
green, blue, green,
Rifkin
red,
lost
green,
control.
red, blue,
He basically just started giggling and laughing uncontrollably during this task, such that we had to stop it and continue, and that's very unusual. Next, I'd like you to put your hands out.
His performance on another test showed even more signs of dysfunction.
Beginning with your right hand, when I go like this, I'm going to ask you to go like this. If I knock once, his response is to lift his index finger briefly and put it down. Now, when I go like this, I'm going to ask you to do nothing. If I knock twice, his response is to do nothing at all, not to twitch, not to move whatsoever.
The objective, once again, to follow a set of rules while ignoring a natural impulse.
Saw a little flinch there.
Out of 100 tries, most people make a mistake only once or twice. But Rifkin failed 16 times.
In other words, he had difficulty inhibiting a motor response, even when he knew that it was incorrect.
What does it mean when someone is unable to inhibit a motor response?
It means that, in this case, they had difficulty controlling their movements, controlling their behavior.
Bolton says it also indicates that Rifkin's brain does not function properly.
Based on my tests, there are strong indications that he had problems with behavioral control and impulse control, and that it was neurologically based.
The diagnosis in the final medical report? Moderate dysfunction in the frontal systems of Rifkin's brain. The frontal systems include the frontal lobe and a section inside called the prefrontal cortex.
The frontal lobes, you can think of them as sort of the central processor of the brain, connected to everything else, mediating everything else, modulating everything else.
Their main job is to supervise, to coordinate other parts of the brain in organizing movement and behavior, making decisions, and regulating impulses, including violent ones.
The frontal lobe provides judgment. It allows us to say, don't say that, don't do that.
Dr. Jonathan Pincus is a neurologist at Georgetown University who has tested the brains of more than 100 killers. He is an expert at evaluating the frontal lobe.
A third of the brain is the frontal lobe. And the frontal lobe is the thing that really needs to be assessed in people who are having difficulty controlling their impulses.
Scientists think the frontal lobe acts like the brain's emergency brake. The theory is, if the frontal lobe is working properly, it keeps us from acting on violent urges. But if it is not working correctly, the urges get through and turn into action.
The frontal lobe probably is not the location of the impulse. It's the location of the dampening of that impulse, the control of that impulse.
The most aggressive impulses begin deep inside the brain in the limbic system. It is one of the most primitive areas, the same area that makes animals lash out when they're hungry or threatened. Many scientists think that without the frontal lobe, these violent impulses would completely overwhelm the brain.
It can be quite a savage place if it's unrestrained, and the frontal lobe tends to restrain it and inhibit it. When the frontal lobe isn't working, it just does its thing.
Dr. Pincus agreed to come with us to Attica Prison to evaluate Rifkin and do his own tests on Rifkin's frontal lobe.
Just watch my finger, but keep your eyes right on my finger.
Just like the exam at Stony Brook, these tests look simple, but they are designed to measure whether Rifkin can complete an activity without getting distracted by other impulses in the brain.
Put your hands on your lap this way, make a fist with one hand, and just tap. Now, with each blow, I want you to alternate. See what I'm doing?
Rifkin makes repeated mistakes, a sign Pincus says that his frontal lobe cannot focus and block out other urges in the brain. For instance, the urge to make identical motions with both hands.
Okay, all right. Just alternating palm and fist strikes is something he couldn't do.
Another test.
Left-handed? Yeah. Okay, so start with your left hand and go like this, and do it with me. Palm, fist, side. Palm, fist. No, do the fist this way. Fist.
Again,
side.
Rifkin struggles.
Palm. You say it as you do it. Say it out loud.
Fist. Palm. Fist. Side.
There you go.
Palm. Fist. Side.
Okay.
Yeah, right side.
All right. Forget it. That means the frontal lobe of his brain isn't working properly. It seems trivial, but it's not. It's an inability to pay attention. He was trying desperately hard to do the right thing and to succeed.
Since each test tells Pincus a little more, he continues until he has a clear understanding of how Rifkin's brain works.
His IQ is superior. It's 120. But the tests that reflect frontal function are defective, seriously defective.
And that explains it.
And that explains why he wasn't able to control his impulses. It doesn't really explain why he has those impulses.
Dr. Pincus came to the same conclusion today that Dr. Bolton did in 1994 after Rifkin's arrest. Joel Rifkin has a dysfunctional brain.
He must have something wrong with his brain. This activity, these thoughts, these urges and impulses are coming from his brain. His inability to control them is the result of brain disease.
The conclusions I drew were that there was dysfunction in frontal systems of the brain. If I had to speculate, I would say it was very much consistent with someone who had a tendency to do things or to have behaviors that, even though he may know they're wrong, were uncontrollable.
In Rifkin's case, the murderous impulses came with a very bright mind, a combination that proved lethal.
The fact that he was able to murder so many people without getting caught testifies to the fact that he was a very high-functioning individual, cognitively and intellectually in general, but had the very specific problems with impulse control.
Even Rifkin wonders if he might be hardwired to kill. He thinks the final answer might lie in a scan of his brain.
You can't fake that. It's either there or it's not there. This is the picture of your brain, and this area is working or it's not working. And it's up to the scientists to decide what that means.